Webhooks provide a way for you to listen to different events that happen in the Stripe API. In the last video, we created a payment intent object, and the state of that object can change over the lifecycle of the payment. There are certain events that we want to listen to and run code in response, like when a payment intent has succeeded or when the payment intent payment has failed. Head over to the Stripe dashboard and go to the Developers tab and find webhooks. Now, in order to receive actual webhook events from Stripe, we need to have a URL that's available on the internet. But that's not something we have just yet, and we won't have it until we deploy our functions in the deployment section of this course. Now, just hypothetically, if you were to create a new endpoint right now, you'd have it set up to listen to specific events from the API. The ones we're interested in are payment intent succeeded and payment intent failed. But again, because we haven't deployed our app to production yet, the question becomes, how do we implement and test webhooks in development? It allows us to send test or mock webhooks in development to localhost, which means we don't need a real URL on the internet just for testing. You'll find a link to the Stripe CLI in the course notes below, and then follow the instructions to install the CLI on your local system. It'll first have you log in and link your actual Stripe account to the CLI tool. Then it gives you the option to forward webhook events to a specific URL, which in our case is localhost 3333, or the port that the server is serving on, followed by the URL, which in our case will be hooks. From there, you can trigger events by calling Stripe trigger with the event that you want to trigger, which in our case will be payment intent succeeded. So now that we have a way to trigger webhooks in development, we need to set up an API endpoint to handle them. Let's create a new file called webhooks.ts, and then we'll import Stripe and define a function called handle Stripe webhook. This function will take the request and response as its argument. Stripe sends the data from this webhook in the request body, and instead of JSON, we actually want a raw buffer in this case. In my opinion, the best way to handle this is to set up some middleware to add a raw body property to the body, which instead of JSON contains the buffer. The easiest way to do this is to modify our express.json middleware to run a callback called verify that contains the buffer itself and then sets it as a property called raw body on the request. And that means we can now access the buffer in any one of our endpoints. Now, the reason we want a buffer is because this is a signed request from Stripe. When we told the Stripe CLI to listen to localhost 3000, it printed out a webhook signing secret. You can use this value to ensure the request actually came from Stripe. This endpoint will eventually be available on the internet, which means anybody could send a request to it. But for security, you should only listen to requests that come from Stripe. And here's how you do that. Go ahead and copy the signing secret from the CLI output. Use it as an environment variable by setting it in the .env file. Now back in the Express code, we'll first grab the signature that Stripe attached to the request, which we can find on the request headers under Stripe signature. Then we'll convert all the data into an actual JavaScript object by calling Stripe webhooks construct event. This method takes the request body, the signature from the header, and also your Stripe webhook signing secret. This guarantees that the data you're working with is legitimate data that actually came from Stripe. The next thing we'll do is create a try-catch block to handle different types of webhook events, because you'll likely want to handle multiple different types based on your payment implementation. We'll go ahead and create a JavaScript object where the key in that object is the name of the event, and then the value is a function to handle that event. The function will take the event data as its argument, and we can strong type this here as well if we want. And the data in this case would be a payment intent object. Now, what you do inside this function is entirely up to you. Most likely you'll be updating a database somewhere, which we'll do with Firebase later in the course. You might also send a confirmation email, send a text message, or do whatever else you need to do to fulfill the user's purchase. Now, if we go back into our try-catch block, we can then call one of the handlers on this object by simply passing it as the key to the object and then calling it like a function with parentheses. And then we'll also pass in the data object as the argument to the function. So this just allows us to reuse the webhook validation code for any type of webhook that we receive in the app. If the webhook is handled without errors, then we can send a successful response back to Stripe. Otherwise, we'll catch the error and send an error response back so we can log those errors in the Stripe dashboard. So that takes care of our main logic. Now let's go back into the API file and we'll set up an endpoint for hooks and simply pass our webhook function as the handler for that endpoint. So that's how you handle Stripe webhooks in development. When we get to the subscription section, we'll look at this in more detail as we implement our own business logic with Firebase to update the user's membership status in the database.